Good evening, everybody. I have to give my apologies, first of all, for not actually being physically with you, but I hope my digital avatar will do the job. So I'm going to talk to you tonight about a British take on design steppe vegetation. And of course, I realize I'm here in the steppe capital of the US in many, many ways. And I don't know if you're aware of this, but of course, in Western Europe, steppe has been an inspiration for planting design for a very long time too. Indeed, from the late 19th century, particularly in Germany. And here we have a slide of some designed steppe in the German botanic gardens created by Cassian Schmidt. Now, clearly, I'm talking about steppe vegetation and sometimes your steppe vegetation from the perspective of a horticultural use in another biome. So I think the way you have to see this talk is picking out the ideas and bits of inspiration, but probably not being able to pick out things which are very, very literal. But nonetheless, I hope you find something rather useful in it. Now, before I actually move on to the main part of the talk, what I really want to do is give you initially just a little sense of where I've come from. I think when people speak to you, it's really important that you have a sense of what shapes their ideas and how they do things. So I'm going to tell you a little bit initially about the university I work at, just to set a frame, and then I'm going to tell you a little bit about me and what makes me tick. And then hopefully the rest of the talk will make a bit more sense. So I live in that building. I'm the head of the Department of Landscape Architecture. There's a lot of stuff there, but you don't have to really, I don't have to go through that. I think I just need to tell you that as a landscape architecture school, we're really big. We're the biggest in the UK. We have about 400 students, which is pretty enormous in landscape architecture. And a lot of those students come from overseas. We normally have between about 20 and 22 nationalities represented within our group. We are correspondingly very international. So about a month ago, we were doing a road show around South America, and we were doing that for a number of reasons. Firstly, we wanted to try and capture some bodies who might come to us. But more importantly, we really want to sort of build connections and increase our understanding so that we can collaborate on research and a whole range of other things, because that's the nature of the organization that we are. I sort of fell for this guy, and some unkind person said we had very similar hair. But quite perceptive, I thought, at the time. We produce a lot of stuff. We are very much a research school, and this is just about a third of the books we've written in the department in the last decade. So we really very much strongly colour the actual language and the conversations in landscape architecture internationally. And if you look at the range of titles, you can see there's things which are everything from the social, the cultural, the ecological, the horticultural, and so on. So we're very diverse. We're not like many landscape architecture schools which tend to be more dominated by landscape architects. We are a very broad church. And I think you'll see that by the end of the talk. We are, for example, the largest horticultural and horticulture and horticultural ecology research group in the UK, but we're in a landscape architecture school. The other thing about it is all our staff, all my staff, I guess, they are all researchers. As well as teaching and some being practitioners, they also have to research by their contract, and they have to publish in the top international journals, and they have to bid for money. And if they don't, sooner or later, we part company. So that makes us very different. We have 3 research groupings. We have social science, we have arts and humanities, and we have ecological and horticultural science. And I'm in the last one. But the thing is that we move around. We don't live in silos. So part of the time I spend my life working in environmental psychology areas. The rest of the time I work in horticultural, ecological type territories. And we have a lot of PhD students, 35 PhD students, so we're a bit of a beast in terms of what we can do in research. As researchers, we want to really ask really interesting questions, and we want to try and make a really positive contribution to the world, but of course we also want people's cash too. And so this is me in northeastern China, and I'm developing a relationship with this university, and the role is to develop the vegetation flora for meadows and steppes in northeast China, and this has been funded by the Department of Transport for the province. So this is the sort of thing we do, but I also work in practice too. So this is in the US, this is in Memphis. working with field operations just on a part of a garden project around a major new parkland system. Here in China, this is me trying to convince some Mandarin speakers who don't speak any English about how we're going to do something really important here. And this is us creating the first sown perennial meadow, actually more like a prairie, to be honest, in this part of Western China. And this is the sort of work we've been doing in China. Now, the thing you need to understand, this is all about sowing seeds to create vegetation. A lot of my work is about that. I do planting too, but you can see it's very large scale. So what we're really doing here with the sowing, we're creating the whole infrastructure of this new landscape in this, what is known as a sort of tourist village, which is a very common new form of development in China. And if you look at this 6 months later, because this is 6 months after sowing, it looks like that. So we're creating these sorts of landscapes, and I work with native species as a restoration ecologist, and I go all the way through to working with horticultural vegetation in the same way as you might have in the gardens outside this building. So I have this very broad spectrum of activity. Chinese like pink and red, so they're probably a bit disappointed with this, but hey-ho, that's how it is. So how do I personally see the world? Well, people often say to me, what are you? Because people always want to know what you are, because they want to sort of pigeonhole you. But in actual fact, I'm really like an edge dweller, and I'm neither fish nor fowl in many ways. So I think I live in this red dot in the middle. So I design things. I have a horticultural science background long time ago. I publish in the research literature as an ecologist. And I also work, when I've got time, in environmental psychology, and I'm really interested in what human beings think of the types of vegetation that we create. So I'll come back to this time and time again during the course of the talk. So what do I want to do? Well, I suppose in many ways I want to try and enhance biodiversity, and that's in a whole range of ways. It's with native plants, with native invertebrates in particular, but I'm also interested in cultural biodiversity. What lives in gardens, especially as increasingly we know from the research done in Western Europe that the average English garden is actually fabulously rich in native invertebrates, even though it's about 99% non-native. So these things are very important in my world. But I think to do this, certainly in cities, and this talk's really all about cities, you've really got to balance biodiversity with human cultural need. Because if you don't, human cultural need is the eye of the needle through which the camel must pass. And so unless you make things which people can broadly ascribe value to and meaning to, then sooner or later the political process eliminates the ecological goods that you might otherwise have created. So I see vegetation as a co-element within landscape architecture, certainly not a technical bolt-on at the end of the process. And I think that's a really important idea. And if there's any landscape architects in the audience, I'd really like you to reflect on that in terms of your practice, because bolting on is still the norm in most cases, and it tends to limit what you can achieve. So my work has really been all about to rethink the use of vegetation in cities, from green infrastructure through to the garden, in response to the following, what I've called policy drivers. Firstly, declining funding for skills and maintenance. Now, some people think that one day the 19th century will come back again and we will have all the resources and we'll have the halcyon days we thought, which of course we never really had, but there's a sort of bit of delusion there. But in Britain, I just don't see that coming. And so my work has been to say, well, what can we do with where we are, rather than what might we do if we were in a different place. So secondly, I want to try and reduce the use of carbon, i.e. energy, and water expenditures. Although you're much drier than us, London lives on the edge of just having enough water to stay afloat. And if you think about in terms of climate change, London by 2050 has the same climate as Bordeaux has today. So we have a 7-degree latitudinal shift in our climate. So the world becomes a very different place. I want to use planting and sowing to deliver function as well as aesthetics. So, for example, how do you contribute to urban water management and how do you support biodiversity? And we need to sort of integrate these things rather than having a sort of duality of, oh, that car park's for parking cars and that's a nature reserve. The car park needs to be a nature reserve, and that's actually achievable quite easily. But until we make those intellectual leaps, we're never going to do that. Climate change resilience, a lot of the work I do is looking forward to the next 50 years. We've got to start thinking on those timescales. But critically, I need and I want to enrich the lives of urban human beings. I want to try and create moments which are really special, which are meaningful. You might call those the dopamine moments, when the dopamine leaks into your brain and you have this moment of exhilaration and meaning. And too much planting in urban landscapes is just about filling space and not about creating and manufacturing experience. So that's important for me. But I suppose the big question is, how can complexity and diversity in planting be created and managed in the longer term outside intensively managed gardens? So that's what a lot of my work is actually focused on trying to do. And the way we've really done this is by developing what we call design communities. So this is where we've broken, in a sense, from traditional decorative horticulture, and we've looked at building things a little bit like a restoration ecologist might see, but in many cases using plants which are non-native to an area. So we've tried to make this crossover, and indeed my professorship is I am professor of horticultural ecology, and I'm the only one in the world. The only person who's identified that name for themselves. So that gives you a cue of what I'm all about. So, hey, I just pulled this slide out. This is not having a go at Denver, but this is in Denver. And so rather than create landscapes like this on a large scale, I'm more interested in trying to do things in the intertussock space and perhaps to do something that's more like that. So that's one of my projects in the UK, using, in this case, little blue stem and North American prairie plus some European species to create something that's much more dynamic, much better resource base for invertebrates, and so on and so forth. To give you an example of what I mean by design communities, I just want to show you this image. I'm currently doing one of the 4 expo gardens at the 2019 Horticultural Expo in Beijing. Now, this is a real fantastic opportunity to change the mindset of, say, many people in China who are really struggling with the idea of how do they integrate ecology into the designed environment, because 16 million people will walk through this garden over the year of its first year. And so what this landscape consists of, it consists of about 4 plant communities. It has a woodland, it has a woodland understory, it has woodland edges, it has wet swales around the edges of the path, so all the water goes off the path and is drained locally through the profile. And then it has a central, hey, this is for you, steppe area, which uses a rather eclectic range of steppe in this particular case. So it's got these 4 communities, and the way these things sort of work, this is just a little, you can see on the plan on the right of the slide, you've got like a red line across. That's a cross-section through what this vegetation looks like. So you've got a woodland understory, you've got the woodland edge, you've got the swale, and you've got like repeating pattern species within these communities. You'll see a bit more in a second how it actually works. So this is the sort of work I do. So everything in that community has to be able to cope with its neighbours, but also cope with the environmental conditions which are in that zone, be it shade or moisture or whatever. And one of the really interesting things about plant communities is they have remarkable properties potentially, very similar to the properties of nature. So if you think about a drainage swale, I spend quite a bit of my life designing or thinking about drainage swales because they're very in vogue at the moment. And what you never know in designing vegetation in a drainage swale, you never know how wet or dry it's going to be. And no one ever knows that. You only know it after it's made, and it's too late then. All you know is that the bottom will be wet, the top will be dry. It's like the 3 bears and the honey. Sorry, that's not honey, it's about porridge. The 3 bears and the porridge. And so when we design, we use a community, so we have a mix of species in A, and they're mixed randomly. You might have, say, 5 species. 1 or 2 of them will probably work in the wetness. The others may have to wave them goodbye as they go into the night. We have a range of, say, 5 species for the dry at the top, mix B. And then in between, we have a mix of A and B, because we have no idea really what the gradient of conditions will be in there. And this allows this vegetation to fit the site without intensive input. So that's one of the nice properties of designed vegetation on a community model. So what I suggest to you is the 21st century trinity for urban landscape plants and planting is as follows. Aesthetics, what does it look like? What does it do? Then secondly, urban tolerance, how does it deal with hostility? Because most urban places are fundamentally suboptimal. Not always, but in many cases. And then thirdly, what does it do in terms of ecosystem services? And the way I see the world, no matter where I'm working, it's always trying to stitch those things together in the work I do. We're very interested in this idea of supporting life, and of course in Britain we're very interested in invertebrates because that's the most obvious life and that's most of the visual biodiversity in terms of fauna. So we're very interested in knowing how vegetation design affects capacity to support life. And because our cities are very plural and eclectic, we're really interested in knowing what lives in habitats which are a long way away from nature, native nature. And so we've got a lot of research on this sort of stuff. So we know now that certainly in the European biome, that nativeness is not really very important in terms of the plants, in terms of supporting diversity and density of native invertebrates. It is for some highly specialized species, but in the main this is not the case. So we try to apply these ideas to everything, not simply when we're doing, say, native nature. It's just as important if we're using begonias or some other alien thing. We're always thinking along these same lines. And I think that's a liberating and important idea because it stops you from boxing things into categories which are not helpful. But of course, also, I work with native species a lot, so I understand the native as a good, and it's very important. But I think we also have to understand that these ideas are important when we're not using natives too. So here's an example of these ideas in some of my work. So this is a stormwater drainage system in a London park, and there's 3 of these things in line in the entrance to a major new park restoration, and they take all the water off the hard surface. And what we're trying to do with this, we're trying to combine aesthetics, function, and biodiversity in a very judgmental political context. This is in late October. And so this is looking good late, and this is really important to our urban public. They need to have these sorts of things. And it's mostly North American because we can only do that late flowering thing in this place with non-native species, because none of our native species flower beyond about July. And so we've quite flexible, and of course our gardens are full of these things, so we expect to see these sorts of things. Now, of course, some of the philosophical strands in how we use plants and how we think about nature and the landscape, they're also very important to me. So I've got 2 of the poles, perhaps, in American discourse about nature. You've got Thoreau in the woods, in his cottage, sort of being in nature and being made better by it. His words, perhaps rather than mine. And then you've got Poland, who's talking about another sort of nature, a nature of more closely aligned to our species. And the dialogue and the conversation moves back and forwards. And I can, depending on the circumstance, I can be with either one or the other of those, or both. So I think we need to see these things very fluidly. What's appropriate, on a roadside in the countryside may be completely different what's appropriate on a roadside in a city. But I think you need to be able to move between these ideas effortlessly and fluidly. So my most intimate experiences with nature in terms of hours spent, and that's coming from someone who spends a lot of his time in the wild, as you'll see in a minute, is via my garden. And here's an example of a garden which perhaps meets some of it's doing some of the things that perhaps I've been talking about. So it's hyper complex, both taxonomically. There's 600 species in this space. It's very spatially complex and structurally complex over time, and we know this is really, really important for invertebrates. It's probably just the most important factor in terms of supporting diverse guilds of native invertebrates. And it's and I just wanted to make, I don't know what you might think of it, so I thought I'd better show a TV crew there, because that would make it good. Because TV is like a universal I can't get the word out. It's a universal, I want to say validification, that's the word, validification of goodness. No matter how crap people think your garden is, if the TV cameras come around, everyone says, oh, well, it must be good. So what we're doing here, and one of the reason I put this slide in, I wanted to try to get this idea across to you that in my world in Western Europe, there tends to be a polarity of ideas that urban culture is ordered and sterile, and that native nature is disordered and rich. And I want to try and get these things to come together so that urban areas can be disordered and rich. And sometimes that will be native species, and sometimes it will not be native species. But if everyone doesn't want to have native species, they shouldn't have to be sterile. If you get the idea. So it's like crossover. It's like changing philosophical perspectives. And I'm very interested in individual species, and I'm a geek. I'm not one of those I'm not someone from the landscape architecture world who only knows 6 species. I know terrifyingly large numbers of species. So I'm really interested in Lomolosia cretica, even though no one uses it. But at the same time, I think about these things in a big context, so I make things like that. That's the 2012 Olympic Park. And now I'm making 20 hectares of native wildflower meadow, forming the entire skin of the park over a 3-kilometer transect. So I'm thinking about Lomolosia in that context, not simply in a pot in an Alpine Garden Society show. And I think that's a really interesting thing to do, perhaps. So it makes landscapes like this. Everything you can see there is made. This is a brownfield site, heavily contaminated brownfield site in 2008. And it's now completely transformed into this native sort of Eden through this sort of work. This is all made by sowing seed in situ. We use 2 tons of seed to make this landscape. And of course, I want you to buy this, because I want to have a better holiday next year, but more importantly, because there might be something interesting in it. It really tells you, it gives you a background over a 20-year period of how we've developed these techniques to make something which seems completely random and chaotic, i.e. establishing vegetation by sowing seed, into a design tool which allows you to do what it says on the can. So we're going to say a bit more about that in terms of some of the techniques. So for example, I've used these sorts of ideas. This is sort of like Eurasian steppe vegetation in Britain, made by sowing. And when I show you a picture, if it's not made by me, I'll tell you. So I won't have to say every time made by me, but it's all sort of part of my work. Or on a smaller scale, here's Cambridge Botanic Garden, just some dry, multi-species origin steppe-like vegetation, again made by sowing. We didn't sow the Eremuris, it's too hard, but everything else is sown. And making this sort of vegetation has made me think a lot about how you use spatial factors to drive visual excitement. So many of us might see planting in the historical sense. You have a square meter of plants, and in the US, you seem to plant at much lower densities than we do, but it'd be quite normal for us to put 16 plants per square meter. And just imagine this is all just one species. It just means that if it's pink when it flowers, it's only pink for when it flowers, and that might be 2 or 3 weeks or 4 weeks. The rest of the time it's not pink. But if you make these individual plants a different species and you pick them to stretch the season, these might, this is what, I took this picture in what I call Mulch World in Baton Rouge, and I see a lot of this in the US. And I think Americans must have, I don't know, I mean, it's a conversation we need to have. We like to hide mulch, but you seem to like to show it. So I don't know what's going on there, some different cultural prerogative. So rather than have that, I'd like to move on and say, well, what if some of the balls flowered in spring? And what if some of the balls flowered in summer? And what if some of the balls flowered in autumn? And then we can do that sort of stuff. We normally make the gag at this point about give me your money, but in terms of the hypnosis, but I don't know if that's really working for you. It's easy to show with colored balls, but how does it work in practice? So this is some planting. This is planting. This is by Nigel Dunnett, a colleague of mine at the Olympic Park, some of the gardens, and I'm going to show you the same space each time through time. So this is in May. This is in June, same place. This is in August, and this is in September. And it's just working because of how it's designed. So you can create these sort of skins which do this over long periods of time. And this is really important. It's really important for invertebrates because invertebrates need supermarkets. They need long seasons of supply if you're going to maintain big populations and potentially diverse populations. And people need it too, because this is much politically easier to sell to people if you've got these long seasons of interest. Because most people will never be very ecocentric. That's a baseline. We think sometimes we will convert everyone to be like us, but that's probably a fantasy. So you have to work with what you have, not to what you'd like to have. And what we do is we use some of the techniques derived from ecology. We create these like phenology charts, and we just pencil in when things flower, and so you get a real sense as a designer about the season. This is for Panayiotis because it's sort of succulent. This is a succulent meadow on the seafront in San Sebastian in northern Spain. It's a rather quirky project, a lot of fun. I also think a lot about layers because to maximize flowering longevity and to maximize spatial complexity, you have to design vegetation in layers. And we tend to think about planting as one layer in many cases, but the way I think about vegetation is you have a base layer, then you add something else to it, and you increase the complexity and perhaps increase the flowering, and then you add another layer. This is South African vegetation. And then you add another layer, and you end up with something that's really, really complex and very different, and etc. But we design in layers. I design in sheets, like sheets of paper, stacked on top of one another. And the way this works in practice, I mean, here's some sown prairie, US prairie, in RHS Wisley Garden in southern England, and it's dominated at the moment when you're seeing it in August by Echinacea pallida. But if you look at the same place in spring, what you have beneath this is that. You have sheets of Pulsatilla vulgaris, which surprisingly enough, as a plant that grows mainly in sun, is actually just shade tolerant enough to exist under the canopy. And so these two things, that's really practical too. Not only does it give you a major event in spring, it also prevents early season weed invasion to some degree within the community, so it makes it more functional in terms of public spaces. So it's been about uncovering and understanding these sorts of processes. So when I create vegetation, I mean, I guess there's two critical bits. There's first of all assessing site conditions. What are the ecological processes going on in that place? And these places are normally completely manufactured, but ecological things go on in completely manufactured places, just like they do on a prairie outside of Denver. You've got to get rid of that idea that ecological process is something to do with nature. It's not. Ecological process is everywhere. You cannot switch it off. It's just there. So we want to know all those sorts of things. And then secondly, we want to know how you can pick species which will fit those conditions. And secondly, how those species will interact and compete with one another. Because when you make communities, it's all about competition between species, and there is no ringmaster there to manage that competition in a thoughtful, intelligent way. The designer has to build in those relationships so it doesn't all go horribly wrong. So you need to have more understanding of these sorts of things. Okay, so I just want to go on now, and I just want to show you the process of developing sown vegetation types in this way. And the starting point is that there's a whole range of things about design. There's some things about science, and there's some things about practice. And I needed to have like a model to run my life to actually work out how to do these sorts of things. I first started doing these things about 1985, working in Australia, and I started working initially on steppe grassland in western parts of Victoria in southern Australia. Not a very different climate to here, to be honest. And I immediately saw the potential as an urban design form in this very rare, almost extinct prairie grass equivalent. So I started developing these processes. So the first thing is firstly, you've got to decide, well, what might be interesting is this conception thing. So I often do this in the shower. I stand in the shower in the morning and I just think crazy thoughts. What might we be able to use? But you've got to have those crazy thoughts, because my work's not about making something which reflects what we currently do. It's about thinking about things which people have perhaps not made before. So you have to imagine it. So it's all about imagining. And then the next thing is you have to find some semi-natural stereotypes from around the world, which might be good models for what you want to do. Now, one of the reasons I want to do that is I'm a professor in a university, in a research university, and I have to publish or they have me exterminated. And therefore, if I work on vegetation types which have a wild equivalent, I can publish that more easily. So, for example, I've published the first paper in the world, for what it's worth, on the emergence characteristics of Drakensberg grassland species, but I did the work in Sheffield. But it's in the South African Journal of Botany. So I need to do those sorts of things. So hence why I do it this, rather than just adopt a very eclectic approach and say, oh, I'll have that species, that species, that species. I do that in practice, but I don't do that in my research project. So if I was here, I'd be working on some of your probably steppe grasslands or something, you know, about using that as a model. And what we've learned to make so far, and it takes about 10 years to learn how to make one of these, but I do have lots happening at the same time in parallel, so I don't just do 4 in my life. So we've done that, we've done that, we've done that, we've done that. And it's about 10 years per strand to make this knowable. It takes a long time. And what's always been really important for me is actually being about being in the wild. And I wanted to be in the wild for lots of reasons. One, I like being in the wild. I'm a bit of an explorer, adventurer. So I get off on that. You know, it pushes my buttons. But secondly, it allows me to really understand, independent of the horticultural literature, which is often rather poor and rather flawed, and it's obsessed by optimality, not tolerance, and I'm interested in tolerance. And thirdly, it allows me to imagine things and make things which people have never seen and therefore cannot imagine. So it's, from a creative point of view, it's really important. So you'll see from the writing on the hillside, I'm somewhere in the Tibetan area in western Sichuan. And I'm looking at the Juga lupulina, some of the dry populations on south-facing slopes, and they're growing in lumps of rock the size of my fist. There are wet populations, there are dry populations. This is a dry population, and they happen to have red bracts, which are particularly nice. And so now when I read that a Juga lupulina needs a wet, moist soil, I know that's complete nonsense. So by seeing it, I know it. That's Jingyu Kai, he's one of my collaborators in China. A day on the Balangshan, very definitely not steppe, but my God, what a place. You know, covered by a Corydalus pseudobarbicepala. What an extraordinary dopamine moment. This covers hectares. So if I get off on these things, perhaps other people will get off on these things. A few weeks ago, I was in Mongolia, and I had a picnic in this meadow with some Chinese colleagues. We sort of rather damaged a lot of it with our rugs, but anyway, but hey ho, you know, that's life or that's death. So Delphinium grandiflorum, you know, and what again, by seeing that, I'd never seen Delphinium grandiflorum in the wild before. I've worked with it lots of times, but now I have a much better sense of what it is as an organism and how it functions. And what a creature. Just across the border, well, not the other side of China, Xinjiang. I was in Xinjiang this year, and this is Salvia deserta, which is really not a cultivated species yet, although now it is, because we collected some seed for the Beijing people we were working with. Big version of Salvia nemorosa, really, but more drought tolerant and better. So just seeing that, it was very exciting for the Chinese people, because they had no conceptualization that even had anything like that in their flora. Or in Turkey, in northeast Turkey, I was in northeast Turkey in July this year, and we saw some fantastic vegetation. There's prangos in the foreground, and Marina persica, and acantholemons, and just seeing these things gives you the design capacity to imagine things which are extraordinary. I'd never imagined Hypericum lydium would form these meadows, these steppe meadows covering the whole sides of mountains. What a fantastic Hypericum. I do a lot of climbing. Most of the world's interesting vegetation is above 1,000 meters because we've eliminated most of it below 1,000 meters. It's just mainly trash below 1,000 meters in many parts of the world, so you have to go up. So here we are on the ridge of the Swartberg, and you know, so you have to do 1,000 meters a day up to see this. And this is why most people don't do this. And this is why virtually no designers do this, because they don't walk 1,000 meters up a hill and 20 kilometers a day. You know, so they're never going to see this, so someone has to do it. And I put this in for Panayoti again. This is Gazania othonites on saline seeps in some of the plateau areas in South Africa. So seeing these things, what an extraordinary plant. Bulbinella latifolia. In Western Europe, we think bulbinellas melt at -1. But this valley here, we know how cold it is. There's a Met station, it's -16. That's centigrade. That's pretty damn cold. Or Bulbinella latifolia doloritica. So seeing these things, wow, what could I do with that? On Niphophia caulescens in a bog in the Eastern Cape, so at 2,700 meters. Or I don't know how many people have ever seen Eremeurus tianshanicus. We drove for 3 hours through this. There were tens of billions of them, you know, and they're 2 meters tall. And what's really interesting when I look at this, look how dense the steppe grassland is beneath it. This is not in a really open habitat. So this population here is probably much more tolerant of competition. So this is really interesting. This is special. I have to go back sometime, perhaps. And you take all these sort of ideas, and then what you do is, through my sort of work, we then synthesize new communities. So in this community, the species origins are eclectic. The Steppe from Spain, the Eremeurus from Central Asia, the Berkea from South Africa. But what they all have in common is they all tolerate drought, and mostly they're what we call stress tolerators, and they're not very productive. So they can actually coexist as a community, even though they've never met each other in evolutionary terms. So we explore that sort of territory. So we do that, and then we move on to the sciencey bit. So we often work with vegetation that there is no literature on, or it's just simply very poorly understood. So often we have to evaluate robustness, hardiness, a whole range of these types of things. So here we are with South African Mediterranean geophytes. We put 100 seed in every pot. And we have multiple replicates, and we subject these plots to different cold treatments in winter, and we see how many we kill, because we actually embrace death. Death is good. Without death, you can't actually evaluate things, and horticulture, we're scared of killing things in many cases. But we're not scared of killing things, and so we then collect the survivors, and then perhaps they become the material that we work with in the future. So, hey, here we have it. Here we have the survivors. Here we have Bulbinella latifolia in Sheffield, in a 53 degrees north, unprotected in winter. And we know about this because we've done the killing, or the not killing, as the case may be. And we've done this with your vegetation too. So we've done lots of studies on penstemon. We've trialed hundreds and hundreds of different species across moisture gradients. And that's a little paper just in the... it's not like a heavy academic paper, but it's very much research based on about 120 penstemon species from the US, because we need to know as designers how many of them will simply fall off the edge and die, and how many of them actually live for 25 years. And some do live for 25 years, but mostly they don't. Then we need to investigate establishment in situ from seed. That's the core of what this talk's all about, I guess. So what happens if you sow 100 seed per square meter of species A? What do you get? How many seedlings? So we do big experiments like this. This is some work with Giolito Seeds in Germany, funded by the European Union. This is a sort of like $400,000 research project. And what we're doing is, the question we're asking is if you sow 100 seed of these 700 species, how many seedlings do you get that actually emerge? And we call that percentage emergence, and it's one of the fundamental things you need to know if you're going to turn sowing into a design tool. So we do that, and we've analysed the data, and we also explore these things, the sowing mulches. When we sow, we can only make this work if we cover the soil with a layer of material which does not contain weed seeds, because otherwise we can't manage the competition. So by doing that, and often we use sand, sometimes we use crushed building, sometimes we use composted green waste. It depends on the community you're working with. We sow into that, we maintain it through irrigation, moist for 12 weeks post-germination, and that's when we stop irrigation, they never get irrigated again. And because of that, we create standardized conditions wherever in the world we do this. And therefore, we can apply our field emergence values to wherever we are. So hence, you begin to see how this becomes knowable. So here's a table just showing, this is just for a community. It's mostly North American that we're creating. And what it's there for is to show you how we turn sowing into a design tool which is knowable. So to do that, you need to know only three things. Firstly, you need to know the target seedlings per square meter. How many seedlings of each species would you like to have per square meter? And that's a design decision for each species in the mix. Things which are big, you want very few, because you want one there and one over there and one over there. Things which are small, you probably want many. The next thing you need to know is how many seeds there are in a gram of seed. And that varies a lot, but it's known, so it's very easy to find that out. And then the other bit of information you need is what's the typical field emergence. And once you have those three bits of information, and all those bits of information are in Sowing Beauty, by the way, for 700 species, you just need that little algorithm at the bottom in red. You paste that into the cell of the final column and you drag it down, and it calculates how much seed you need. Hey, presto. A design tool is created, which you can use on anything. And then you multiply that by 10,000 if you've got 10,000 square meters, and you've got the amount of seed. Now, that's not what happens in prairie restoration. That's an entirely, we have no idea what we are doing process. And that's why it has a very low likelihood of giving you what you want to have, because it's essentially random. And then we write a paper. We write a lot of papers, because otherwise we get the sack. And then we look at long-term community development, because it's one thing to make vegetation. It's actually quite easy to do that. What's more difficult is how do you manage it and keep it for many, many years, because we don't want to make this as just like a 2-year wonder. This is to be permanent or semi-permanent. So what we have to do is we have to understand from an ecological point of view and also a horticultural point of view how this vegetation changes over time. So what we do is we use a technique derived from ecology called microcosms. So these are 2 by 2 meter squares, and they're like a part of a bigger community. And in this we have 54 squares. This is South African Drakensberg vegetation, 6 months after sowing. And we run these experiments and we apply management treatments across them, and we run these for 5 or 6 years and we see what happens. So it's like you design something and then you run it to see what it really does, not what you think it's going to do, but what does it really do. So this is year 1. This is year 2. You'll notice the change. Things which are tiny in year 1 are a bit bigger in year 2. Some things grow very quickly, like the Berkeas and the Diaceas, but they might not be there in the longer term. By year 5, it's dominated by one of the monocots, by one of the geophytes, about Nyphophia uvaria. And so this allows us to see who's going to be the competitive dominant. There's always a competitive dominant. Always, always, always. And you reduce the density of that in the mixes accordingly. It also allows us to see which species are potentially weedy invasive, because over a 6-year period, you get a pretty good idea of that. So I just want to throw that in, because obviously I'm showing you lots of species which from a British nation state perspective are aliens. So we want to work only with species which are non-invasive, and we work with species that are known as stress tolerators. And virtually none of the world's invasive species are stress tolerators. So these are intrinsically slow and steady and rather pathetic plants, and they're not very likely to be invasive. But of course, as well as doing these sorts of things before we apply to practice, we really want to know what people think. So we've got this guy here with the Union Jack on and the ridiculous hat. And what's really interesting about him is he's taking pictures. He's a man, and he's taking pictures of flowers, and he's a working class man. I can tell from what he's wearing. And working class men don't take pictures of flowers in my culture. It's not done. So something's happened in this guy's head. There's been some moments of transformation in his head. So I'm really interested in knowing why all those people are taking pictures. So I work quite a lot as an environmental psychologist. And just to give you a sense of that process, here I want to talk about how flower densities flower density thresholds are intrinsic to human preference for disordered, natural-looking vegetation. So this is the same place. Some prairie vegetation I made in a Sheffield Park about 2004. And every month, as it changed, we interviewed 50 people who were walking past it. And we tried to establish what they thought of this, and actually, as it changed its appearance. So in the first picture on the top, this is when it's just beginning to start flowering. It's mainly green. It's really messy and chaotic. There's no human patterns or cues in it. So many people just see it as weeds. And they can't manufacture value in their heads. They say things like, it's just trash. Why is that there? This is shocking. It's disgraceful. Why is this in an urban place? What's the management doing? And that's how they respond, more or less. About 40% say they like it. They're the ecocentrics. And they've self-selected. That's why they're in this place. If we did it at a bus stop, there would be 10% of these people. But we've self-selected because only ecocentric people go to botanic gardens in the main, or they're more likely to go. 40% think it's trash and are very hostile and negative to it. A month later, it's flowering. They all love it. And they say things, they cry and say it's the most beautiful thing in the world, and all that's changed is the flower density has increased. And we now know that flower density is over 30% of the surface area being coloured. Most human beings find that deeply meaningful. And now people have a sense of value about that, and they say how wonderful it is, and why can't we have more of that in public spaces? I spend my life teaching landscape architecture to students about things like texture is good, but they don't see it. It's a niche. It's within our bubble. Ordinary people don't see that in the main, but we don't recognize that. So we write some more papers, and so, this work's all about the wow factor. How does the appearance of vegetation affect people's capacity to engage positively with design vegetation? You should read this. This is a really important bit of work. It just was published about 3 months ago. Really, really significant for our niche. Okay, so we got to the end now. Now we've got to practice. So now we want to make it in the real world, because that's ultimately what my work's about. It's not about wearing a white coat and being a research scientist. And we want to do it, and we want to make dollars if we can, because we need to support the program, and we perhaps want to have better holidays and all those sorts of things. I'm going to show you a little video just to show you how this process works in practice. This is for the Oxford Botanic Gardens. Small project, about 1,000 square meters. So not small in horticultural terms, but small in Olympic Park terms.
In 2008, the University of Oxford Botanic Garden embarked upon a major redevelopment of the lower triangle at the garden. This area was first planted in the 1940s, and all the trees and shrubs had become over-mature together. So the entire site was cleared, the site was levelled, and then the area that was going to be the new border was covered in 3 inches of sand that was raked and rolled to be totally level. Professor James Hitchmough of Sheffield University had devised a plan with plants from 3 different geographical regions, from the Mediterranean, South Africa and North America. Tom Price, the garden's curator, mixed the seeds to a very precise recipe. James then came down to Oxford, the seed was mixed with sawdust and then spread over the entire site, ensuring that the seeds were randomly spread through the mixture. Once the seed had been sown, it could be raked carefully into the sand before the whole area was covered in jute netting, a very loose weave so that the plants could grow up through the holes in the matting. This matting is there to hold the sand and the seeds in place. In the spring of 2011, it was very bare. In the summer of 2012, it looked a bit weedy, but by 2013, we had created a new wow feature at the Botanic Garden. And here is James talking to a group of visitors about the border.
With these sort of borders, potentially there is no edge. And so you've got, instead of like borders like tearing up, so it's very dark and shaded towards the back, here you have a much more open system, And that does mean things like Indian paintbrush can potentially operate in the middle almost as well as on the edge. And it's the same with a lot of the other species. So I mean, what we've tried to do here and what we'll try to do in the longer term through management is to maintain that sense of openness, so we get lots of light coming into the middle of the plantings because there's no need to tear up. And that will then allow us to keep a lot of the small species which need a lot of light, and you can have these effects cutting right across the planting. Because I think that's why this is visually striking, because patterns sort of repeat and they're not just confined to an edge. I think we'll kill it there, because that's all you really need to know. Okay, so one of the problems about doing steppe type vegetation in Britain is it's too wet. We have quite light rainfall, but we have a perpetual drizzle every few days. And so we have a range of issues in steppe that you would not have here compared to our maritime climates. So I just want to run, before I look at a few case study projects, I just want to run through some of the more, what you might call ecological horticultural management issues that, for example, we face. So what are some of the strategies you can use to make potentially quite open vegetation more manageable in maritime climates, or indeed perhaps in any climate, because I'm sure you have some of these issues too, albeit at a lesser degree than we do. So one of the first things we do, we like to use vegetation on very infertile, i.e. unproductive. So as an ecologist, I talk about unproductivity. Productivity is just a measure of how much biomass a system will produce. And of course, horticulturally, we tend to think that systems which are highly productive are better, intrinsically better, and our whole gardening culture takes us that way. But given the option, I quite like to work with things like crushed building, because that allows me to engineer things. The problem with productive soils is as they get more productive, they produce more biomass, and then you get more competitive elimination within the community. So this is one of my green roofs in my garden on top of my potting shed, and you can see it's got virtually no nitrogen in it. It's a 75mm layer of crushed brick, and we have all these Central Asian and Turkish and other species growing on it. So that's a really nice sort of system for this very open end of the spectrum. In spring, it looks like that. And Peter Korn, for example, in Sweden, he's trying to do similar things, and he's using deep sand to achieve the same. So he creates extraordinary vegetation by doing this. But one of the interesting things is that even at close to zero nitrogen levels, you still get very stressed ruderal weeds in the system. You can see these nursery epilobium in here, and they're sort of irritating. They don't actually do much in a harmful way. They're too small, but they're sort of irritating. So by itself, low productivity cannot eliminate weed invasion. It just makes them small and makes it more manageable. So it's useful, but it doesn't solve all the problems. And at some levels of nitrogen, some species just can't do it. This is some sort of steppe-like planting in Sheffield around an arts installation, and those species are just too stressed in terms of nitrogen. So you've got to get a balance between how much, and it's mainly about nitrogen. The second strategy you can use is to increase plant density to close down spaces between plants in spring. So this is experimental work here. We're creating, this is one of 96 blocks, and we're creating Mongolian grassland communities with a Mongolian student in Sheffield. And then we're doing the same in Mongolia too. We have a parallel research. And when this fuses together in a few weeks' time, this is actually very hard to invade, even though it's very unproductive and relatively open. Thirdly, you select species with dense basal foliage to inhibit the establishment of seedling weeds. This makes a big difference. And this is particularly if this layer is beneath the canopy and is shade tolerant. Now, of course, some of your ecosystems are very different here. They're very dry, so you can't do all of these things, but you can do some aspects of these things. And then this idea of combining two or more layers of foliage on top of one another to maximize light exclusion at ground level. This is I'm speaking to you as ecologists now. You know, this is how they talk. This is what it's about. It's about light exclusion. So this is just some work we were doing for this project in China, the expo, and this is just to explain to the Chinese how these concepts work. So I don't know if any of you speak Mandarin, but Panayiotis does, so there you go. And so this idea that you have a base layer, and then you have a secondary layer, and then you have a tertiary layer. So this is also very powerful. I'll show you some images later on this. So in my home garden, this is in March, and it's a lot of geophytes and dodecathions and little rosette things, perhaps 25 things per square meter. Very, very diverse. And then the same place in June is that. So everything is underneath, and it's either gone dormant or it's highly shade tolerant. And it just means that this system is much more manageable because the gaps are closed when the weed invasion tends to take place. One of the key species in my garden is this, Ranunculus gramineus, which is a little sort of steppe plant from southern Europe. But it has the appealing characteristic. It grows between autumn and spring in a maritime climate. It's dormant from May. And so you can use this plant, which is very intolerant of shade, under canopies above because it goes dormant, but it's not dormant when it needs to be there. So it's a clever little play on phenology. The fourth thing to do is to utilize deep surface mulches and materials that dry very quickly after rain. This is a stormwater system which runs for 1.2 kilometers through my city in Sheffield, designed by my colleague Nigel Dunnett. And if we look at what's below that, so this is very complex, sort of some, you might say, messy planting, but beneath it you have this deep layer of gravel, and the plants are planted into the gravel, not into the soil. There's soil beneath, and the roots escape and go down. But this system won't work as well because it's got too many fines in it, and you'll get too many weeds establishing on the surface because of a moisture film. So this is not right. They've got it wrong. A much better example of this is some PhD research projects, and this is just pure washed pea gravel and washed crushed limestone on the left. Sorry, it's limestone in front, and it's pea gravel on sorry, it's limestone on the right, and it's gravel mulch on the left. And the plants are planted into these 200 millimeter layers. 3 years later, there's no weeds in the pea gravel. It's never been weeded. It's just things just don't establish in it. It's just too hostile. But it has to be deep. And then we also look at other things, like an application of what, as an ecologist, I would call a spring disturbance. So even with all these things, you tend to get some seedlings. And if you've got no one to weed these things, in public space, probably no one will weed these things. And so we have to try to find a way to get around that. They might pull the odd big thing out, but they're not going to be on their hands and knees pulling tiny seedlings. That's not going to happen. That's a delusion. So what we do is a third of the blocks are burnt at 500 degrees C. We just burn over the top of everything, like hoovering the floor, like doing a carpet. A third of the blocks we spray with a vinegar, a concentrated vinegar, just what you'd have on your fish and chips. And that causes the cell membranes to rupture, and it just acts as like a contact defoliant herbicide. But because it's vinegar, we're all very chilled about it. It's not a toxicological problem. If you've got people who are worried about vinegar, then they need help. But that's a problem for you, not for us. We're pretty chilled about it, perhaps. And after you've burnt, you've got that. And then 3 months later, you've got that. Most of the species just come back, and we're doing this in leaf. And if the species can't work with this treatment, then they're no use. We find another species that you can. And if you look at some of the data from this, what you can see from here is just that weed invasion on gravel is significantly less. It's statistically less. And if you spray, weed invasion is significantly less than not doing anything and burning. So vinegar is very good. And if you have gravel and spray together, you have no weeds. It works really, really, really nicely indeed. So just to finish on, I want to show you a few case studies of the application of this work to practice. I showed you Oxford Botanic Gardens before, and this is Oxford in Gardens Illustrated. And it's, what does it say? It says, blah, 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 blah. James Hitchmough has provided a modern masterclass in sustainable planting for the 21st century, which is probably a little bit of an over-egging the pudding. But nonetheless, I don't care if Gardens Illustrated thinks it's good, you know, because that will seduce society to also think these things are good. or at least the middle classes. So these are the species that we use, and you can look at these at your leisure, because I think we're going to make this presentation available to everyone as a download. So in May, this is the Eurasian community, and you can see how complex it is. Pulsatillas have just finished flowering. Same place in June, July. And again, you get a sense of how incredibly complex it is. Same thing in August, and then in September. And then the North American pieces, these are early successional species which are going to die out, but by year 3, 4, they're still there, but they're going to go, and it's designed for them to go. And then we have the South African species. This is like the South African Drakensberg steppe. This is in about May, June. And the same thing closer up. So you get a sense, and I see the tussock grasses of Themida triandra, etc. Now I just want to show you some on a slightly bigger scale, much more public scale. It's much easier to do things in Oxford Botanic Gardens than it is in the Olympic Park, because the Olympic Park is a public park now, and it has all the problems that public parks have. So here's the site. It's big. It's about 2.5 kilometers across, and on your right of the screen there's gardens along the river, and I'm going to mainly show you those, but also some other things too. So one of the vegetation types we made there was a sort of sown sort of steppe, dry meadowy steppe, and it's got things like, you know, alliums and Papaver orientalian, got a bit of planting too, and we made this as a temporary vegetation along development frontages, and this was only meant to be there for 3 to 5 years. But it's been very successful. It's called the stitches, because it stitches through the park wherever the entrances were punched through after the games was open. And it's been a real revelation. And it's got pretty low maintenance. Again, it uses what we call low nutrient topsoil, which is sand. That's the top 100, 200 millimeters of the profile, and it just makes things ecologically possible, which are impossible with soil. Soil is the enemy, I'm afraid, in my world. Perhaps not in yours. And you see the Eremurus and the Niphophis, and this is really pretty extraordinary stuff, and there's thousands and thousands of square meters of this, so this is really powerful for the public, and I have to say very, very good for invertebrate biotas too. But it's just temporary stuff. It's going to eventually be swept away. And then we did the gardens, and I've shown you this image already, and it's just my sketches for the structure of the Drakensberg gardens that were going to be there as part of the garden system. It was meant to look like this, and that's what it really looks like. So not bad. I was quite pleased with that. And from above, it looks like that. So you get an idea of the design genre, the design style. That's still there today. We made that in 2011, and it's still pretty damn good. I took that photograph last week. That's the North American prairie garden in autumn. And so again, these things are long persistent. And then finally, I just want to show you the Fidelity International project, which I think is a really nice project. It's the banking headquarters of a finance house. And so the building in the center that curves is full of merchant bankers, not an entirely loved species in the present moment in time. But nonetheless, we thought it was important to give them joy. And so what we've done around this site is a whole range of native and non-native vegetation. The pink stuff is North American prairie vegetation. And this will get a sense that the scale is big. These are thousands of square meters. And they're made by sowing. And so here we are in August 2010. And this is really interesting, much more interesting than it looks, because the soil here is not soil. The soil here is a building that was previously there that we crushed on site. So this soil is crushed building, mostly crushed concrete, so it's very alkaline. It's got no nitrogen. It's got quite a lot of phosphorus and potassium in it. And we mixed it with subsoil clay, and that saved them £250,000 in terms of taking the building off site, so they were very happy. And it gave me a chance to play with North American prairie steppe vegetation at very low nutrient levels. And when I thought about doing this, I must have been insane, because these people are highly litigious, and I didn't really know how to do this. But I said yes anyway, so in a moment of madness. So we had to try and make it work. So this is the first year, and this is only about a third of it. There's a lot of it. and they look out of their windows from moving money around the world. And this is what it looked like in 2016 in about July. But this has a long season from about May through to October. And other bits look like that, or that. Asclepias tuberosa really likes this site. It's fantastic on it. It's just doesn't do this most places, but it does it here. And this is what you get. You get this idiosyncrasy in a lot of these projects. You just get a species on that site which really, really works. And I think this is good. I don't know what you think, but I think this is fantastic. And we have a very good management relationship here. So we go every year and we give feedback, and they pay us to go, and they take notice of what we do. And so it's a great model for how all these sorts of projects should be, because you can't do this sort of work with a conventional design approach of we make something and we walk away. You need to have management as part of the process forever. But it's hard to get that change in how people see the world. But if we want to live in a better world, we have to start doing that. In winter, just before they cut it down, it looks like this. I try to get them to leave it till late March, April, because by doing that you get less winter weed invasion. And they've always lied to me and said they never cut it down until March, but they do, because the people in the bankers, they thought the bankers would moan. And by doing that, they open it up and they get lots of ruderal weeds. This year I've eventually nailed them down, and they didn't do it until April, and they get very few weeds. And then they burn it. They flash burn it. Just over the circuit. We cut it all off, take it away, compost it, and then we do woo-hoo, like that with a 500 degrees. And that produces very, very nice clean vegetation. And if we don't need to do it, we don't do it, but we do it if it's contingent upon how many seeds there are. So that's really it. So I'll just leave this to you. So with these two ruminants ruminating about life in a Chiswick meadow. So thank you very much.